that brings us to the second use case, and this is a popular one that you might have seen recently, which are essentially the voice assistants, which are also based upon some of the class of algorithms that we are talking about. Okay, so there are different voice assistants. I'm sure that you might have come across one or some of them for sure. For example, Apple has Siri, Amazon has Alexa, Google has Hey Google, and also for Windows application you have Cortana and so on, right? So you may have used some of these voice assistants, which essentially takes your voice and converts it into different useful things. Okay, so this application is based upon the main this topic, which is known as automatic speech recognition. So all of these voice assistants are essentially built upon these ASR techniques that we are talking about. Okay, so what this ASR technique is that you have a microphone and somebody speaks in that, that is basically recorded as a some sort of vibrational frequency, and then from there you convert that into a text. So for example, the Valentine's Day is coming in a couple of days, and maybe somebody is speaking Happy Valentine's Day. So the automatic speech recognition algorithm will take that as an input and essentially convert that into a natural language processing context, and then this could be again passed on and done different things in this overall pipeline. So how this pipeline works, right? You typically, whatever you have as a input, which is basically the vibrational frequencies, right? Based upon that, you will take that and you will do the feature extraction. You will pass them into a decoder, and this decoder is essentially a deep decoder in many of this voice assistant or ASR machine learning pipelines that you have. So what they typically do is they have trained a deep neural networks, which basically takes these complex features and then decodes that into maybe a condensed form or a decoder form in a latent space. And this mapping is done through multiple deep neural networks. So you have multiple layers within, and by training this network on a large-scale data set, you essentially have a feature space to a latent space mapping, which is very, very accurate. And once you do this decode, this overall frequency information or the input information is now decoded into a latent space, which is a small space, in which now you can start using the acoustic model and the language models that you have built that will help you on understanding what that text is. Again, so here we are mainly doing with machine learning and natural language processing, or and so on, and this also has its own domain information. So you need to understand what acoustic models are, what language models are, in order for you to create something like this. Okay? So this is one application. Now, what is happening? I think this technology is going to percolate in our everyday life. I mean, right now, at least my kids are definitely interacting with Siri and Alexa. I'm sure that it's someone or you yourself are interacting. Here is another example of how ASR is going to be used going forward. There is a company called Starbucks here. Now you can speak on the the proposal is like in the very near future, you can open your Starbucks and you can talk to the ASR or the voice assistant of the Starbucks, and you can say, I want my latte with this and this, and it will automatically take that natural language processing and convert that into an order. And by the time you start from your home and you reach the Starbucks outlet where you're picking up the coffee, all that will be taken care of by you. So what only you need to do, you do not need to go there and order specific and talk to the person. You can talk to your phone and the app of Starbucks, and that will take care of all the ordering process. And so the many applications like this are coming, and you will see that ASR is going to be a prominent field, which is based upon this decoder and the acoustic models and other things, which are essentially the class of deep neural networks techniques that we are talking. So that's the main technology underlying implementation of ASR, which is going to impact various different things. I am in automotive sector, manufacturing sectors, and both of those sectors are basically being transformed by deep neural network, perception, identification of pedestrian, identification of lanes, and so on. All of these are various applications where the deep neural networks are there. So I see the field growing tremendously, and everyone now, if it is a good corporate, a large corporate has their digital policy, and they have to have this experienced people in data science and machine learning who understand these things, understand the concept, and probably have a team that can execute things like this, right? Another popular example of ASR, which might not be like a voice assistant, but you might be using, is this automated captioning in YouTube, right? So you have a video, and also on video you have a voice of the person who has recorded this video. What they do is they take the voice one, and they basically have a deep neural network that automatically takes that voice and converts that into an English word, which is essentially typed. So nobody has to do this captioning and provide the captioning aspect themselves. This is automatically generated for you using a machine learning algorithm. So the YouTube caption generator, or anywhere where there is an automated caption generator, you are essentially using the class of deep neural network techniques that allows you to take the speech as an input and convert that into a text, right? And that's the main part of any ASR technique that we are talking about. Okay, so that's another